Welcome everyone. Today we'll talk about layout planning in this particular video. So we'll understand how a facilities has to be planned based on the types of production that we are looking into it, or an office setup has to be done based on the customer flow or the workflow that goes around it. So let us proceed with the agendas as to what will needs to be covered around, right? So first we'll discuss about the definition, what is meant by layout planning, the types of layout. Did I say about manufacturing? Did I say about an office which is service oriented? Probably. So different production or different concept or different objective of setting up a organizations will have different kind of layouts, and so we'll talk about the layout, which is SOUL kind of scenarios, the setting arrangement or manufacturing there. So based upon the types of layout, we should understand that there is basically the process layout and the product layout is what we are looking into it. Did I say if we are designing an office flow, we can set up the layout in the way the customers has to visit or in the way the work has to be processed. So this needs to be done, decided upon it. Similarly for product layout, what kind of manufacturing are we doing around it? Is it batch production? Is it mass production? Is it an aligned concept? Is it an assembled production? Depends on the product layout goes around it. Yes, we are going to talk about the steps involved in designing a process layout, definitely, which is very important. So what about product layout? As in process layout, we will also discuss everything about the product layout in this presentation, and thereby we will love to appraise you about an hybrid layout concept where the best of either of the layout we can take it and consider it for setting up our plant, our offices, or any premises of commercial interest. We will talk about cellular layout also, which is based on the group technology product, as the case might be. So let us begin with what is layout planning. Definitely, yes, this is one of the points that we need to cover around. Layout planning is deciding the best physical arrangement for the resources within a facility. Yes, that is what we are looking into it. Physical arrangement. Why? Because that means and less movement of workers, less spillage of materials, and so on and so forth. So in a way, if we can design it where there is a less wastage, less effort to be put in, it just optimizes our productivity or production facility thereby. Facility resource arrangement can significantly affect productivity, as I have already stated to you people. Now, there are two broad kind of operations, right? Broad. One is an intermediate processing system, and the other one is a continuous processing system. What is the intermediate processing system? Is having a small batches production of different products. So product, let us take a shampoo for a strong hair, for an oily hair, from a thin hair, and so on and so forth. For every types of hair, we are going to produce different kind of shampoos, right? Definitely. So that is what we are looking at, small batches for different kind of products. Essentially, we are shampoo manufacturing company per se, as far the example is concerned. So that is what intermediate processing system would always looks to be. On the other hand, if it is a continuous processing system, it's a high volume of few standardized products. Let's say we are having one particular models of car that has been produced, right? One particular model of car, so everything can be done on a standardized fashion. So it's a continuous processing system. The only differences is the car color can change, which can be done at the very fag end of the process. So that is the difference between the broad categories of intermediate processing system and continuous processing system thereby. So talking about the types of layout, there are basically four basic types of layout. Now, what are the four basic types of layout is what we are looking into it. They are process layout is something which we need to go around it. Process layout is having similar resources. For example, painting might be one divisions that can be taken care of. Designing can be one division that can be looked into it. Quality can be one division. It's basically similar resources put together. Or there can be something called a product layout designed to produce a specific product. Did I give you an example of hair shampoos based on a thin hair, thick hair, oily hair, and so on and so forth? The types of hair that we are going to go around it, or the medicated shampoo that we are going to produce around it. So it's product specific, So that will mean it will produce the product much more efficiently. A cost effectiveness comes around it, and in between, if we can have a mix of a product and a process layout, is all about hybrid layout that combines best of the both layout. And then obviously, yes, fixed position layout is something wherein product has to move to a too large to move. For example, a building, it's something which we cannot go around it. I have given you an example of a building for a purpose, but probably there might be huge materials or equipment. Let's say a coke oven which is producing a steel approximately at 1800 degrees centigrade or 2700 degrees centigrade. The coke oven cannot be shifted here and there, so everything has to pass through it. So the once you have decided upon the fixed position layout, can't help it anymore, right? So that is what we need to go around it. Let us understand the process layout out here. Process layout has a unique characteristics, and it includes wonderfully things which are basically clubbing each activities under one simple head or under one premises. For example, resources are used as a general purpose that comes around it. Yes, we are talking about it. Facilities that are less capital intensive or more labor intensive. Resources which are flexible, absolutely. Process rates are slower, takes more time to process, and material cost handling are very higher. So you need to keep your inventory bare minimum, or should I say you should always keep a check on the inventory, because any spillage, any wastage out there, it costs huge onto your productivity and profitability of the firm. So yes, resources which are generally for the general consumption, facilities which are either of a less capital intensive or more labor intensive. Similarly, resources having greater flexibility and processing rates being on a slower or a faster rate, and material handling costs are higher. So scheduling a resource and workflows are more complex in a process flow, because we need to understand if there are certain process and there are bottleneck in one of the operational steps, you know, it differs or it affects the rest of the workflows altogether. So scheduling is becoming more complex. Space requirement is definitely higher, because it is all about the process that we are looking into it. Now let us come to the product layout. Now what are we talking about product layout? Remember, product layouts have wonderfully unique characteristic. Why? Because resources are specialized, unique product that we are coming around it. Facilities maybe or usually are capital intensive. Processing rate, definitely it is. We are coming up with the product until and unless it's a process where there's a service orientation. But in product, the rates, processing rates are faster, because many a times it is the standard product, and many a times the standard product is having a little of a variation, as with the shampoo example that you can notify. Material handling cost definitely is lower. Space requirement for inventory storage are lower, but then there are many companies who would love to make to store and then build, then sell it all around it. So they are going for bulk production. In that case, the material storage or inventory storage might be higher. But usually, we are right now witnessing a just-in-time production (JIT) concept that has been utilized around it, where space requirement for inventory storages are bare minimum. Flexibility is low, definitely, when we compare it to the market. So that is what the characteristics of product layout will be going around it. So let us understand the process layout and the product layout. What are the differences and how do we go around it? Remember, in process layout, we are able to produce large number of products. Probably that is not possible with a small number of products that comes around with the product layout. So process a large number of products, layout would have only a small number of products. Now remember, resources might be of general purpose, where it can be specialized in terms of product layout. So in terms of processes, resources are general. It can be generic in nature. You know it, you have it. But in product layout, it pertains to a particular product. Facilities are more labor intensive, definitely, yes, absolutely. And this can be more capital intensive, because we are talking about standardization. The moment we talk about standardization, we are going for mechanization or fully automatic production, which might be capital intensive. That might not be the case as far as the process layout, which is essentially more labor intensive than anything else. Greater flexibility relative to the market. Yes, we are very conducive or receptive to the ideas of the customers. Orientation. Low flexibility when related to the market. That is what we are looking into it. Process layout are slower. Processing rates are very faster in product layout. High material handling cost and low material handling cost in comparison with the product. So process layout would have definitely high material consumption because you are customizing thing, when product layout would be having a low material consumption, material cost, because we are standardizing it and everything can be predefined. Higher space requirement in process layout, which might not be the case as far as uh, product layout is concerned, which is looking at a very lower space that comes around it. So these are the various differences between the product and the process layout. And if we can come up with a hybrid layout model with the best of the both layout process, be it the process one or be it the product one. Now, what are we looking into it? Maintain some efficiency of product layout and definitely maintain some flexibility of the process layout. If this can be done, this is what we are looking at, a hybrid optimization of production, or should I say the layout of the facility thereby. Example is GT or group technology and manufacturing cell, or let's say a grocery shop. A grocery shop, you go to a grocery shop, probably you will have a host of uh, items made available to you, right from uh, edible things to fast moving consumer good things, probably to some kind of electrical things also. It is everything which is it is available under a similar loop. So we are, this is what we are looking as far as the layout is concerned in terms of group technology and manufacturing cell. So what are we looking at? We are trying to obtain the best efficiencies of product layout, and at the same time we are looking for the best qualities of flexibility in the process layout. So fixed position layout, did I say when equipments are very big, probably I've given an example of building in this particular slide, but when equipments of coke oven, the example that I have already discussed with you, used when the product is large, product is difficult or impossible to move, that is very large or almost are fixed, all resources must be brought to the site. Scheduling of the crews and resources is definitely a challenge that we are looking forward to it. So let us come forward with designing the process layout. Thereby, what are we looking into it? Step one is to gather information. And what kind of information are we looking into it? We are looking at the type of space needed, available, and identify certain ambiguity between them, what is required and what is available. So availability might be a little less or considerably less, or little more or considerably more. So how do we plan the space than what is required? Similarly, for step two, develop an alternative block plans. Probably if it is the space is less, can we have multi-story building, or probably can we build upon the foot space in terms of certain number of stories that can be added upon it. Develop, basically we are looking at trial and error methods altogether. So develop detailed layout, consider exact shape of a department, work centers including aisles and stairways with the exit and the entry position that needs to be taken in case if there is any unfortunate incident that comes around it. Tools like drawing, 3D models and things like that, you need to keep in account every now and then. The CAD, the computer aided software, is available to facilitate this. This is what we are looking forward to. So special cases of process layout, how do we go across this? A number of unique process layout require particular attention, in terms of warehouse, in terms of office layout. In warehouse is where we can go for production or probably inventory. An office layout where we need to keep an accounts, handle customers, probably have employees walking in and walking out. So warehouse layout, let us understand what are the consideration for warehouse layout. Primary decision is where to locate each of the department relative to the dock. Now, when I say dock, it is where the bay area from where either the finished product is shipped out or the raw materials are shipped in. So this is what we need to go around with the docks. Department can be optimized and minimized ID in totalities and in terms of work jobs, job IDs, work IDs, employee IDs. So if we can have minimum fuss in and around it, it means we are increasing the efficiency thereby. So department of unequal size require modification, typical ID calculations to include calculation of ratio of the trips needed. So the number of trips that one person needs to go from one workstation to another workstation and so on and so forth to and fro back and forth as many as often amount of time in a shift. You need to understand these ratios of trips and you need to see that this will entail a toll on the workers' productivity or performances. The uses of cross-docking modifies the traditional warehouse method. That means more docks, less storage space, and less order picking. Absolutely yes. So if we can have something like a counter system, something like a teller system where everybody can come in, ship in, get the things done, and probably everyone is receiving and probably processing the thing as on when on basis. That is what we are looking at as far as the warehouse layout is concerned. So let us have a look at to the office layout. Office layout consideration. Remember, almost half of the workforce works in an office environment, as the case might be. If you look into it, that is what is true as of today. Almost half of the workforce. Why? Because essentially we are moving from production environment, production economy to a service economy, and that is the reason. So human interactions, communications are primary factors in designing an office layout that needs to be taken into consideration with the passage of time. If we do not understand this, this is going to be a botheration in due courses of time. So layout needs to be accounted for. Physical environment, yes, the psychological needs of the organization. One key layout trade-off is between the proximity and privacy. Absolutely. Open concept office promotes understanding and trust. Flexible layout incorporating the office landscaping help to solve the privacy issues in open office environment. That is what we are looking as far as office requirement is concerned, right? How do we process it and how do we go ahead with it? Designing product layouts. We will be talking about designing of the product layout. In this, what are the things that needs to be kept in mind? Absolutely well required. See, first the sequence of tasks. We need to move on from one workstation to another workstation. If we can have a seamless flow of tasks, seamless flow of work, nothing like it. That means there is a less spillage of material, less effort being put in by the employees. So it has to be in a logical order, and definitely it enhances the speed, or should I say efficiency altogether. The speed consideration, the line balancing effort needs to be taken into account. So let us identify the steps. Did I say in the agenda part of it that we will be talking about the various steps that comes around it? So first and foremost thing, which are the predecessors for an event to take place? So you need to define the predecessor event, not the culmination event or the after step of a event altogether. Why? Because after event can only be starting if the predecessor event has already taken place. So step number one is to define the task which precedes the event altogether. Next step would be to define the output rate. Yes, definitely yes. What we are looking into it, what are the productivity per employee, productivity per time, per hour, per shift, and what we are looking at it. What are the standardized rates? How are we benchmarking ourselves? Then comes determining the cycle time of an work altogether. Compute the theoretical minimum numbers of stations as in when are required. How do we go ahead with it? Step number 5 and 6 is basically nothing but probably allocating tasks to each workstation. Now this is where we need to balance the line, as there cannot be one area which can be task heavy and the other will be very task light. Similarly, not all employees should be equally be shifted or defined as to what kind of job that they are looking up to. Compute the efficiency, idle time, and the balance delay time thereby. This is what we are looking forward to it. Definitely, yes. So I am giving you a pictographical representations of having the events and the predecessor event. Now, this particular task, if you know around it, if this is this representation is known as CPM. If anybody's heard about it, probably well and good. If not, we can always Google it out. CPM is critical path method that goes around it. If you look into it, the flow of the work is comes from this direction to this direction, right? So 60 seconds for task A, 5 seconds for task B, 25 seconds for task C, and so on and so forth. Now, what are we talking around it? If you have followed my other videos altogether, we've been talking about the Pizarro thing. So task A is all about rolling down. Probably there are no predecessor. We start at this point of time. This takes 50 seconds. Then placing the cardboard backing, which is of 5 seconds. Sprinkling cheese. Probably having the sauce being spread around it. Adding pepperoni, all the toppings, the sausages, the mushrooms, the shrink wrap, pizza EFG. This is what we are looking into. It might be optional, pack in a box, and total time which takes around is approximately 3 minutes or less than 3 minutes, 15 seconds less than 3 minutes is what we are looking at. So this is what step number one is all about it. Now we'll come to the step number two. So Vicky needs to produce 60 pizza an hour, and now we have already required understanding that this is 165 seconds it takes to complete everything, right? So determine the cycle time. It's the amount of time each workstation is allowed to complete its task. Remember, cycle time is equal to available time divided by desired time, and this can be in any of the metrics that we are looking into it, in seconds, in minutes, in hours, or probably in days also. So depending upon the availability of time, similarly the desired unit can be in units, in hours, and so on and so forth. That is what we are looking into it. So 60 minutes per hour, or 60 seconds per minute, or 60 units. So we require a 60 unit per unit, seconds per unit as thing. So limited bottleneck, the longest task, what are we looking is 72 hours if you go around it. Now what was my available time was 3600 seconds per hour. In an hour there are 3600 seconds only, and bottleneck task or extra time that we need to go is 50 seconds per hour. So we can actually come up with 72 units of pizza per hour, as the case might be. So step number 4 is computing the theoretical minimum number of stations that we know going around it. And if you're looking at 100% efficiency, what means that every second has been utilized productively. So that comes around it. We have already known that to make a pizza, it takes around 165 seconds, provided the dough is already ready out there. We just need to knead it and probably start with it. Divided by 60 seconds per second, that means approximately 2.75 station, or if we total it out, an extra 0.25 station has been added. That means there is a lag time, and there it is a freebie time. So 3 stations is required, which requires always round up and no partial workstation. Serves as a lower bound for of an analysis to understand how many layouts has to be taken care of. Now let us come to the step 5 and step 6. The penultimate stage is tasked to arrange this tasks which take the longest eligible thing from the precedences and continue the longest eligible task that fits without going into the desired cycle time. And that is what critical path method will actually tell it to you. If you see the eligibility tasks, the workstation 1, 2, and 3, if you divide the work around it, you see 160. See, did I say 165 seconds is what we are looking to make for a pizza? We can divide it in the works around 60 around 3 minutes, and how we go around it is what exactly is happening out here. So workstation 1 will have the lowest possible tasks. Then we have the workstation 2, which has C, D, E, F, G. Remember, E, F can also be done from workstation 3 also, which will entangle approximately total cumulative space of having the maximum number of output per workstation at the most efficient fashion. Last but not the least would be your efficiency and balance delay, if there are any. So you have 165 seconds as the production of your pizza that comes around it. We have worked around 3 stations per into multiplied by 60 seconds. So there is an efficiency ratio of 91.7%, and there's a delay that comes around it, which is almost equals to 8.3%, as the case might be, has been delivered to you, and that is fair enough. We are being very fair and not been very claustrophobic as far as allocating the task or probably getting things done. At the same time, we are optimizing our production abilities thereby by leaps and bounds. So did I say the shape of the line is of SOUL during the initiation of my introduction part? SOUL, what does it mean? It's not a soul that I'm looking out, it's a layout that comes around it. We can have a layout in this format. See, whatever writing it down, it looks, everybody can work out here, sit out here, probably get things done for this table, this table. See, the idea is the person working around here, in case this gentleman or this lady does not turn up, can also shift and probably do the work. So that's the advantage of SOUL. So every letter will tell you the workstation and the planning of the workstation, sharing of resources, enhancing communication, visibility, and impacting the location leading factor thereby. Similarly, for the paced versus unpaced line, paced lines are using automatically enforced cycle time, as the case might be. we are looking to pace our process as with the passage of time. Remember, the production need not be compromised, come what may. So number of products, models are being produced. They can be single. Single means continuous production that we are looking into is mixed model lines. Definitely, yes. I've given you a example of the shampoos where we can have a number of variations of shampoos that can be produced with this kind of process. The last but not the least would be a group technology or cellular technology. Look what is happening with this pictographic. We have an unorganized parts. Everything is randomly placed, and then probably we can parts which can be organized with the help of a when we can club them together towards one another. See, look what is happening. A female part and a male part has been done out here, the steps been taken care of, the levers that can be taken care of. So we are having the turn part, the geometric parts, the form parts, as the case might be. So that is one of the most popular hybrid layout of the group technology, or the cellular layout comes around it. Remember, group technology has their own advantages of bringing the efficiencies of product layout to a process layout environment within the case scenario. Now, process layout forms something like this. If you look into it, this is very confusing, right? I do not know whether you are finding it or not, but this to me is very confusing. It's a simple fabrication unit that we are looking into it. There is a welding, there's turning, there's heat treatment, there's milling, forming, and raw material. So a lot of processes come this way, a lot of processes come this way. Then there is a time lag between one has to depend upon this line. These are pertinent things. The raw materials comes into the forming part of it, without which, or should I say, the finished product can come be like this. The finished product can be like this, depending upon the path that we are choosing around, right? This is the process flow of a GT. So what are we looking into it? We have one unit, two unit, and probably this is my third unit as the finished product that we are looking into it. Now, can we simplify it? Definitely we can simplify it. Somewhere down the corner, we can club the raw materials out here. Absolutely, yes. We can have a heat treatment because they are going to go through, and then we can have singular cell of FNW, singular cell of FNT, and FN something which is very altogether done. Now, this is known as the cellular technology or group technology that we goes around it. I hope everybody is understanding. See, what we have done is we have clubbed similar activities as in raw material and heat treatment as a separate unit altogether, and in between whatever the ingredient steps processes which was in the variation, probably we have clubbed together, and now it is very organized, and that is what the process flow of or the use of the GT cells utilize it. So facility layout across organization, layout planning is organizationally important for an efficient operation. Marketing definitely is affected by layout, especially when the client comes onto the site. If the client comes onto the site and finds that things are very messy, things are very unorganized, it doesn't seem to portray the right picture, right? Similarly, human resource is affected as a layout impact of people. Finances is involved as a layout changes can be very costly endeavors. It can be a very costly affairs altogether. Now, if things are very haphazard, there are much more spillage, there are much more wastages, probably, and that leads to an escalation of cost. More importantly, for the human resources, certain people might be dominant. As a result, their things might get done when get processed. Certain things might not be as dominant, or should I use the word submissive, or they are polite. As a result, their products comes delayed for no fault of them because somebody is dominating upon them. Now, what I'm trying to do, it can affect the morale of the employees thereby. So within an operation management, how does everything, the layout fits together? Remember, the layout decision is directly related to the product design, or should I say the process selection. That job design as a process layout tends to require greater work skill and do more product layout. Remember, it is just the layout which is actually increasing the efficiency. It is actually decreasing the wastage. It is actually improving the morale of the employee. It is actually increasing the delivery, shortening the delivery time of a product altogether. So degree of automation as a product layout tends to be more capital intensive. Definitely, yes, with the advent, or should I say with the adoption of the automation process, So degree of automation definitely aids up to you. Now JIT concept I've already told you within the during the presentation is the just-in-time concept that comes around it. So layout decision comes as on when on basis. I've also said the dock area. If we can have multiple dock area, that means everybody can chip in and every can get the process flow from the moment it has docked, instead of being docking at one singular area and then there is a lag time, waiting time that comes around it. How do we go around it, is which is dictated by the line flow, is with the help of a group technology which we can grow around it, as did I say about the raw material and the heat treatment plant, which comes up with the three different products in my previous slide. So as layout decisions specify the flow of work through the facility, they impact every aspect of the operation management, absolutely, as the case might be. So in short, let us give you a summary altogether. So layout planning is decided on the best physical arrangement of all resources, absolutely within the facility. Proper layout planning is very important for efficient running of the business. Otherwise, there will be much wasted time and energy as well as confusions. There are four basic types of layout: process, product, hybrid, and fixed. I have said in the very initiations of the presentation. I again repeat: process layout, product layout, hybrid layout, and a fixed position layout. Remember, process layout is based on similar process. Product layout is always arranged in a straight line fashion. Hybrid layout is combining the best of the process in the product layout. And fixed layout is something which we cannot do because there a product, either the product is too large or probably the processing space is more or less fixed as such. So process layout provides much more flexibility and allows production of many products with a different characteristics, whereas product layout on the other hand provides greater efficiency. It economies of scale that we are looking into it. It actually, since the number of products are limited, products are almost standardized, we can push down the, or should I say, hammer down the cost altogether. The steps, now let us steps. First, the steps for process layout would be gathering information in terms of space needs, space availability, and closeness requirement of the department, development of a block plan or schematic of the layout, and developing a detailed layout thereby. Similarly, the steps for product layout are to identify the tasks that needs to be performed and their immediate predecessor. Second would be determining the output rate, determining the cycle time. Fourth would be computing the theoretical numbers of workstation. Fifth, assigning the tasks to the workstation. And the last one would be computing efficiencies and balancing delay if there are any. But it is always recommended that we have somewhere down the corner 8 to 10% of delay, so that you can always give a uh, assurance to the customers, and you are assured of yourself also that whatever you commit will be delivered on time because of the lag period that comes around it. So hybrid layouts have its own advantages over the other layout because they combine the element of process product layout to increase the efficiencies thereby. An example of hybrid layout is group technology or cellular layouts. The group technology is a process of creating groupings of products based on similar processing requirement as the case might be. Cells are created for each grouping of product, resulting in more orderly flow of product through the facility as the case might be. So that is what entails. It reduces anomaly, it reduces confusion, it reduces anarchy altogether, and that is the beauty of group technology. With this, I come to an end of this particular presentation. I'm sure everybody has understood why layout planning is so important for in the operation management, and how does it impact the bottom line of any organization. Thank you once again for watching this video till the end.